I have no idea what she's talking about. I'm so excited.
Okay, we're right in the middle of review stuff. So instead of a daily check, we did example 5 and did not have time to do a couple on our own. So while he's blabbing, you gonna do 5A and 5B. Arc functions. Arc sine, arc tangent, arc cosine.
What was that? Inverse.
Inverse, yes.
Morning, all Wednesday.
Okay, so while he's blabbing, you take care of 5A and 5B. We're just going to keep motoring through our review, maybe get a little into 4.2 today.
Activity today, 4 p.m. softball feature. Blackbird State University. Morning. Start time. Until after school. From Dixon from. For you, both on Thursday and Friday this week.
This might.
Okay.
It barely gets through. I need to reload the super staples. And Robbie got kind of grumbly at me because we don't have this kind in the office. So.
Student council meeting Friday, April 14th, games in all student council again. Club meeting today. During lunch, Dr. Jim. ACT math review after school today, Mr. Sullivan's room. Thursday, tomorrow, during part-time Mr. Spears' room. If needed, that's easy after school. Talk to Mr. Spears. Sophomores, next week, April 19th on Wednesday, during blocks 3 and 4. You'll be with your Spark Night teacher taking your pre-ACT test. All students, you bring a pencil, all sophomores, and a calculator with yourself in the test. Identifying information on answers completed Monday, April 17th, during Spark Time. Sophomores, you be here on Monday during Spark Time, and then all afternoon Wednesday. Juniors on the day, taking your thoughts, go to assessments on April 19th, 20th next week, all day in each room. When we find to be closer, juniors need to bring a charged computer with them and wired headphones, not wireless or wired headphones. You have something to check out.
I definitely thought.
Juniors have meant to take next week, Wednesday.
Way too easy.
No, it should be.
Interested in the West River Math Contest. Here, we've done very well for about 10 years in that. Well. Then Gentlemen Book Club, 108 today, there's here. Prom is Saturday. Grand March is at 7, prom's at 8. Post prom's at 11. Make sure that if you are bringing an out-of-school guest or a freshman or sophomore, that sheet must be turned in by 9 a.m. tomorrow morning. 9 a.m. tomorrow morning. Go ahead and read it. Did you find out boosters will host their gala on April 27th? Celebrate. See you again at 6:30 that evening. Program begins at $5 for tickets for that. Complimentary for all. Find out seats. Who does it anyway? Turn the out in town and animated from. Stevens of Whitenburg. Find out the teams of 2. Event will take place April 27th. Friday, end of the 4th quarter. Plan accordingly. You have 1 part-time to get with your teachers. You have today's a white day, third day, and then 1 more white for the. So please stand for the pledge.
Flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, so now there'll be a GSA meeting today. Oh, have a great week.
Did you know? Wait, let me count. My birthday is in 3 days. How are you for a birthday? I do.
Okay, those should have been pretty quick. Remember, the idea was you identify which of the trig functions you're dealing with, and then if in a regular function like sine of theta, it gives you a ratio. So input domain is angle, output is ratio. When we go to inverse, you'll put in the ratio, you'll get out the angle. Okay, inverses, swap domain range. And notice, what was it yesterday? We said all of our sine and cosine values, remember they were all proper fractions. Hypotenuse has to be the big side in the triangle. So that means that the ratio was always going to be between -1 and 1. Hint, hint, the ratio is always going to be between -1 and 1. There's our fourth commandment of domain. Okay. So we'll talk about it more as we're getting into section 4.2 here. But green. Yeah. We say from this angle, I got a 14, that's opposite. I got a 16, that's adjacent. Nope, hypotenuse. So I'm dealing with opposite and hypotenuse. It's sine. I'll do arc sine of. Now you can put in 14 over 16. You could also reduce it and call it 7/8. But theta is this, and then you give me the decimal equivalent. I heard 61.0 for serial. 5. Okay. Oh, whatever you mentioned. Next one. From here, I've got an adjacent and I've got a hypotenuse, which is cosine. So we'll do arc cosine of 5/12, getting a boot. 65 and change. Cool. So, there we go. If we back up a slide, do y'all remember all your parallel line theorems? Oh no! They're not parallel yet. You have to put the symbols on there to show that they are parallel. I just back to page, the thing with the plane. And then, do you remember what that's called? Parallel lines and a, not a bisector. Starts with a T. Transversal.
You want to start?
Okay. Do you remember what 1 and 5 are called? I said, if you know the parallel line theorem, SOHCAHTOA, triangles are 180, you're good to go. What is 1 and 5 called? Corresponding.
I knew it.
Okay. What about 3 and 6?
Well, it's like
Those are triangle congruence theorems.
like that. We don't have to do that, do we? Right?
I'm asking what they're called.
They're called opposite, interior, exterior, south.
Okay, it depends on your curriculum. They will be supplementary, but 3 and 6 are called consecutive interior angles. Some textbooks will call them same side interior instead of consecutive. I know, I just don't like it. Yeah?
Why do they use thick words for that?
Because they're the correct words.
No, but like,
It's almost like we can use polysyllabolic vocabulary.
what's that? That's a big. You know, you have to very No, but like if they would have network stuff, they should have made it small.
All right, what about 2 and 8?
Oh, those ones are like opposite exterior.
Boy, y'all got hosed by whatever book you were in. Alternate exterior. It's supposed to be alternate or consecutive, and then interior or exterior. Okay, what about 5 and 7? Vertical angles. Okay. Well,
They didn't ask what their names were on the ACT, but they'd be like, if the measure of angle 8 is something, 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 what is the measure of angle 3?
okay.
I feel like if they said the names and like what are the angles?
It's 8 and 6 are
The 6 is what?
It would be,
Yeah,
it
so
would
that
be-
means
Yep.
I feel like
what you do is you subtract 8 from 180. And then
If you know one of them, you know all of them, right? Like if I said this was 120 degrees. Oh, how about another one? What are 2 and 3 called? They are supplementary, but what are they called as a pair of angles? L. Linear pair. Okay. So it makes a straight line. That means it's going to make 180. So this is 60. And then you just ping pong your way around them, right? Vertical angles are congruent. Alternate exterior angles are congruent. Alternate interior angles are congruent. Corresponding angles are congruent. Okay, vertical angles here, corresponding angles there, and so on and so on. Okay, so why do we talk about that? Because words. What happens when we get those word problems that are talking about angles of elevation and depression? Okay, remember that angles of elevation and depression are based off of the horizontal. Okay, height is perpendicular to ground, or whatever surface you're talking about. So height is perpendicular to ground. Ground is parallel to horizontals. And you have to remember that the amount that one thing has to look down is the same amount that it has to look up. Because what are these? Alternate interior angles, and they're congruent. So angles of elevation and depression are going to be the same. What you got to be careful about is I will see kids time after time after time. It'll say someone's on top of a building. They're looking down at an angle of depression of 43 degrees, and you draw the picture. And someone draws stick figure building, parking lot. I'm looking down at a thing, and they'll put 43 degrees right here. Remember, it's from the horizontal. They're looking down 43 degrees, which means this is actually 47. So you can choose to put it here, to put its complement here, or just put the 43 down here at your angle of elevation. Okay, so just reviewing the setup of all of those, because here come the words. We also get to see your stick figure drawings. A ground crew worker who is 6 feet tall is directing a plane on a runway. If the worker sights a plane at an angle of elevation of 32 degrees, what is the horizontal distance from the worker to the plane? I now remember my old notes. There was a height of the plane, and I forgot to put it in here. I'm just going to BS it and say that it's 300 feet in the air. Okay. So, stage one. When in doubt, draw it out. The old geometry axiom, right? So, we have stick figure Steve. The ground. We're We're going to have our plane not drawn to scale. Oh, wait, hold on. If anyone remembers elementary school, it's not a plane unless it's got fire coming out the back. Jet plane. Oh, wait, hold on. Then it's got to have like missiles and. Okay, so we got stick figure Steve is 6 feet tall. And stick figure Steve is going to look up 32 degrees at plane. Plane, we said, is going to be 300 feet in the air. Be careful that stick figure Steve's angle of elevation is going to be here. Right? I don't go from his feet up to the plane. I go from his eyeballs up to the plane. If they told me his height, then I have to use his height in my problem. If they don't tell me, then I'll just assume whatever. But if they include the height, then I have to include it in my problem. So, nice part about horizontal and height is I know they're perpendicular. Now what? Okay, I got me a triangle. All right. Because the plane is 300 feet in the air, but his angle of elevation is from 6 feet up, I have to know that this triangle is actually 32 degrees here, 294 feet here, and they want to know the horizontal distance to the plane. Which is just like where we left off yesterday. It's a matter of setting it up. You got to be able to translate those words into a figure. Okay, you don't need to go full, elementary school art project on it, but from the 32, what two things am I dealing with? Opposite, adjacent, or hypotenuse? Which is? Which is? There you go. The tangent of 32 degrees is 294 over x. I can either cross multiply solve, I can Jesus fish, or I can swap my extremes. X is 294 over tangent of 32, or about how far? Uh-oh, someone might have used that calculator since yesterday. Check your mode. Check your mode. That's tangent.
70.49.
Oh, were we supposed to change it? Hold on. They got after I'm done. Yep.
49 who?
I like the calculator's handwriting. That is not what
I'm converting it to if there's ever another word problem that deals in feet, I'm converting it to meters.
Are we gonna get stopped? Why? You're like.
Why? I'm gonna say this many feet or this many
Yep.
meters.
Oh, yeah, I thought.
3 places at a minimum. Unless we're dealing with money, 3 places at a minimum. Okay, I've had that rule in place for 12 years now because I know it works. Even if you can't work with the expressions, going out to 3 decimal places will get you very accurate answers still. Okay? So, Now, did you actually do the unit analysis for it, or did you just dump it into Google?
No, I clicked convert on the calculator. English to metric conversion.
Speaking of, do y'all remember unit analysis? Physical science? Meters with meters, hours with hours, minutes with minutes. Section 2.
I love that.
Oh yeah, it's coming back. So, start with stick figure Steve is climbing the mountain. Go.
A 1,500-foot mountain. What does he live in? The Netherlands?
Wow, that's a tall mountain.
Maybe Belgium.
No.
B, that's like Mount Everest.
1,500 foot, that's, I mean, a little over a quarter mile.
My mountain is like Mount Everest.
Something like that. I could find that.
It's not that much.
No, it's like a mountain.
This looks
Like,
like
that would be going to the top of, the ones in between the J of the interstate, right next to Mountain View. It'd be about like that.
Lookout? Oh my gosh, this guy's falling.
Lookout Mountain?
Is that Lookout?
Yeah.
Huh.
He's falling off the mountain.
Lookout 4,000. 400.
That might be its elevation. That's not the height of it above the town.
I love flying.
Well, they don't specify.
We'll look up ahead of time and that's before I like do all my work.
I have a question.
The exact thing that I said up there that we don't do, you did. This is 36. How much they look down.
Okay. Okay, so my question is, what if the mountain's like tilted? How do you know that that's a right angle?
Because it says how high it is.
Oh.
And height is always perpendicular.
Okay,
So-
perfect.
Is it just like 90 degree then?
Yes. That's what allows us to do right triangle trig on these, is height is always measured vertically, perpendicular.
Why don't you draw it?
Remember, we're not going to measure your height sideways.
It's just, what is the horizontal distance? I made a mishap somewhere.
Because we're dealing with horizontal and vertical distance.
Oh, that makes sense.
So how do I get a,
Oh, we can change it. We can say someone's going to zip line from the top of the mountain down to their campsite.
no,
How far are they?
well, I know we don't zip line. Can I draw? Yeah. It's not a distance. Because you know that this is one.
Oh, don't you do this crap again.
Oh. Well, we're trying to find this
Yeah, so then
between the campsite.
So it's the same.
Sammy, you're the smartest person.
It's the same thing that you had.
You're like Albert Einstein.
I would convert it to meters and
Got it.
that's like gorgeous. I just drew them floating.
If you have the tent going like that, you need a bottom.
I
like,
drew a
show
tent
the
too.
ground.
Look, we
like exploding. Look, we drew a tent. Okay, so like now what?
Well, that's a one.
Oh,
Well,
let's all look at it like this.
no. You have all the angles, but you don't need a cut.
Frank, you cross-eyed Alabama redneck mother.
Thank you.
Power of Christ compels you.
Oh, I did it wrong, Sammy. Don't listen to me. I now see what I've done wrong.
Okay.
Don't worry, Sammy. Yeah, wait, Sammy, you got this, right?
Yes, it literally is. It's gonna go up and then over because the angle is the
Okay.
The angle of depression. This is my triangle.
Oh, they've got no neck. Yeah. Stick figure Steve on top of the mountain, 1,500 feet, and so many feet away from campsite. If this is 1,500 feet, and we want to know that horizontal distance, really that's all that matters. Okay. What you got to be careful about is the angle. It's a 36-degree angle of depression. Like I just got done saying, that's here from the horizontal. So I can either take 90 minus 36, getting a 54-degree angle here, or I can just put that 36-degree angle down here. Okay, it's going to be tangent again because we're dealing with horizontal and vertical distances. The tangent of 36 is 1,500 over x. So x is 1,500 over tangent 36, or about
2,064.573.
so almost half mile.
Oh wait.
That's what I got at least.
2,000 and change.
391 miles.
Wait.
629.282 meters. Or 2,000.
Yeah, we're just going to have to deal with also some sloppy handwriting. Frank is being really, like, this third of the board, the alignment is super off and stupid.
2,064.573.
Shouldn't the 1,500 be on the bottom? And you multiply it over?
No?
Yeah. Because opposite over adjacent.
I did what he did.
Yeah, opposite over Jason, 1,500 over x.
Look at that. It was angled. This is a nice campsite.
It is. Oh, I used 54.
Oh my God.
You can still do that. Does that still work?
Because if you're going from 54 and I'm going from 36, that means that our opposite and adjacent are going to be opposite, and I'll get the same answer.
Started something like definitely wrong according to what you said, but I got the same answer. What? I put the 36 degree up next to the little dude.
That just means that you would have drawn that triangle instead. It still has the same horizontal and vertical distance.
Oh, okay. I guess it's showing.
It has the same. See, mine would be stick figure Steve would go down the mountain and over to campsite. Yours is stick figure Steve is going to like fly over here and then fall down.
That's what mine is.
Okay? It's going to Superman jump and belly flop onto his campfire. Okay? All right. So, that's a bunch of stuff. And then we go to solving a triangle is I give you 3 pieces of information, you find the other 3. Do you remember, what is it? Oh, you were just talking about the triangle congruence theorems, like angle, side, 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 angle, side, those kind of things. Notice that every one of those, it's 3 pieces of information. I will start with 3 pieces of information. I have to find the other 3. Depending what I start with, well, that determines my process. Right now, I'm given one angle and a side next to it. That side next to it is what? Opposite, adjacent, or hypotenuse. So I can now use an angle and trig ratios that involve adjacent to solve the other two. So from here I have adjacent. I might just have to start this stupid thing over and just record this afternoon. If I have adjacent over here and 35, this would be what? Opposite. And if that is opposite, then opposite and adjacent is tangent. So over here, tangent of 35 is x over 10. Or x is 10 tangent of 35, or about number. Now I could use that and Pythagorean theorem to solve for z, but what if I goofed? If I goof finding x and then use it to find z, I've domino affected my answers. So I want to instead just use another trig ratio to find z. Adjacent and hypotenuse is cosine. So the cosine of 35 is 10 over z. Cross multiply solve, Jesus fish, swap your extremes, whatever it is. Z is now 10 over, shut up Frank, cosine of 35. Got smart boards older than you, but let's go spend $2 million on a new tech center. Don't make sense. What do we get for numbers? I heard 7 point. And
208. She's right.
how do I know if those are the right answers or the right places, or at least reasonable answers? Both of those, yes. Start with triangle proportionality. Just look at them and do you have the biggest side across from the biggest angle, smallest side from smallest angle? Okay, so it looks reasonable. Then, if I have these values in my calculator, it should have Pythagorean theorem work perfectly. Okay, I'm in degree. Back to the beginning. If I take the square root of this was 10 over the cosine of 35. 10 over the cosine of 35. Instead of finding the values and then inputting them later, I'm going to type it directly in. If I take that, come on. Shoop. There we go. Squared. Hypotenuse squared minus leg squared. So 10 tangent of 35. Close it, squared. If I do hypotenuse squared minus leg squared, I should get leg, right? Ta-da. By putting in the exact values like this, instead of the decimal equivalent. Okay, look at what happens if I use the decimal equivalent. This is why I wanted to use 3 decimal places. When we say that was 12 and change? If I do square root of 12.208 squared minus 7.002 squared, I ain't going to get 10. But if I go 3 places, look at how close I am. Okay? This is where my 3 places rule came from, is doing this in geometry. Okay? So if you go 3 places, you're still going to be pretty flippin' accurate, because how many of you, when I started typing this, started going a little cross-eyed? Okay? It's just the expression. The expression's the same thing. I'm just substituting it in. But that can feel fairly complicated. Okay? Go over to the other one. I'm given different set of information. So if I have the 2 legs, what else can I find? I can find the hypotenuse. What I don't want you to do on these type is find an angle and then use your trig values to find the hypotenuse, because then you're going to have a trig value rounded off hypotenuse when we can find a hypotenuse that's a simplified radical. We can find the correct answer by doing good old Pythagorean. So it's a hypotenuse. I'm going to do square root of leg squared plus leg squared. 64 plus 121 is square root of 185, and I'm pretty sure that doesn't have a perfect square in it. Okay. Now, if I had 13 point blah, 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 versus I had square root of 185, guess who's going to get that little tick mark next to that one on test and say, find it for real? Okay. Or we'll underline in the directions as specifically as possible. Okay.
But proposition, what if I find fault with that? And do like approximately, like this is approximate. Is that acceptable?
Then instead of the frowny face of doom, you get the happy face of contentment. Okay. Now I need to go find an angle. Which angle you want to find? It really doesn't matter. Just find one of them. If we're going to go from angle J, do I have opposite, adjacent, hypotenuse? What? Well, now I've got all 3. So it's your choice. Don't use the hypotenuse, though, because we might domino effect into this answer. Using the 8 and 11, from this angle, we've got opposite and adjacent, which is tangent. So I'd say the measure of angle J is the arctangent of 11 over 8. Because I'm finding an angle.
You always use that when you find an angle.
Arc functions find angles. Arc function angle. That's also why I normally call them arc functions instead of inverse functions. Now, you're going to get some decimal for that. I could come over here and say the measure of angle L is arctangent of 8 over 11 as well. Or, if I find angle J, what could I do? Better than 180 from 90. Right? Because 90 is already here. That means these 2 angles are complements. I could just take 90 minus answer. So what do we get for those 2? 53.9. And for L? Okay. So it's going to depend on which set of information you're given. And this is also why we didn't start with the daily check. This is also why we didn't have a assignment yesterday, is I wanted to do all of the things, because the assignment will be something as simple as, here's 2 triangles, solve. Solve means find them all. Okay? I mean, you have that choice. Kids always ask, can I do thing? And I say, of course you can. You have autonomy, you have choices. You might not like the consequences of those choices.
So I will do it the correct way. With my own little attitude. What can I do? That's not a good one. Oh.
That's what I mean by Frank is off. So I'm trying to write with that.
Well, the first one was fine.
Yeah. Uh, 900, 210, 420, 1320, 1369, 400, 969. I don't think there's anything in there. So, if you ever look at my keys for stuff like this is usually how I'm writing it. Not a bunch of extra work off to the side, because we're past geometry. Check me before I wreck me. I walked away without a question mark. That's a really bad Frank disrupted 969. I don't know if there's a perfect square that goes in there. I don't think there is. Okay, solve means find everything. I'll give you 3 pieces, you find 3 pieces. I never did the whole attendance thing.
Isn't 36 squared actually 132? 1,136. Am I crazy and calculating wrong?
Yeah, 1369 minus 400.
What is wrong with percentages? Turns out to come
Yep.
Yeah, I'm just raw numbers.
Checky McChecky. I might be wrong. I'm tired. I got screamed awake at 4 again. I might be wrong. Oh, on the first one for A and C, yeah, you can just find 1 and then subtract from 90. I just wrote both calculations because I don't know how you started the problem. Yeah, work smarter, not harder. You don't have to do both calculations. Just subtract from 90 for the third angle.